So let f of x equal x squared for all real x. Then let's say we want to do the derivative at a particular point, like x equals 3 is what I chose in this example. So then f prime of 3 equals the limit x goes to 3, f of x minus f of 3 over x minus 3. That's the definition. We're taking the limit of this quotient, which is the difference quotient right here. And the derivative is the limit of that difference quotient, which is what we're trying to find. So that equals the limit x goes to 3, x squared minus 3 squared over x minus 3. Again, remember, by definition, in this example anyway, f of x equals x squared. And f of 3 would hence be 3 squared. So there's that. But remember, 3 squared is just 9. And so that's all I do here is just replace 3 squared with what it is, which is 9. But lo and behold, x squared minus 9, that's difference of squares. That's x minus 3, x plus 3 multiplied. But then, after that, the point of factor in the numerator was that it enables us to cancel this x minus 3, this which is up here now, with the x minus 3 that's been down here now, for a while. So we cancel these x minus 3's, and we just get the limit x goes to 3 of x plus 3. But hey, that's just a trivial polynomial, a linear polynomial. We have continuity. We can just throw 3 directly into x and get 3 plus 3, which is equal to 6. Okay, so that's nice. And now I'll do another example. Instead of using 3, I use just an arbitrary letter C in general. Now this is actually going to be valuable because this will let me know what f prime is for a general C. I can just roll that number into C if I want a particular number later on. So f prime, my derivative, is the limit of my difference quotient, which is this. But then now in this example, f of x is x squared, so hence f of c is going to be c squared. And so we divide like that. And then we can cancel x minus c's, and we just get the limit x goes to c of x plus c. And so, but that's, again, a linear polynomial. Just throw c into x, you get c plus c, which is 2c for any real c. Now the thing is, guys, x is my variable, c is my constant. Just remember that. Okay, x is moving, so to speak, c is not. C could be anything, but once you pin it down, it's pinned down. That's sort of the moral of the story there, okay? Now again, let f of x equal 5x squared for all real x. Then f prime of c is going to be the limit of this difference quotient. Now this time, f of x is 5x squared, and so f of c is going to be 5c squared. So we just do the subtraction right here. Now at first, you may be a little bit, well, what are we going to do? Well, we factor a 5 out of the numerator just by algebra. We get this guy right here on the numerator where my cursor is. Just follow my cursor. But then, by the rules of limits, we can take the 5 all the way out here, and we just get x squared minus c squared. But remember, I went ahead and did a second step. I factored x squared minus c squared as x minus c, x plus c, by difference of squares. And then the x minus c's cancel, and you're just left with the x plus c in a similar fashion as before. But hey, lo and behold, limit x goes to c. Well, my limit's a little off there, sorry. But limit x, or the fontage is off. The x minus c should be directly underneath here. But anyway, so the limit x goes to c of x plus c, you just, that's a polynomial, that's just c plus c. And you just get 5 times that c plus c. That's 5 times 2c, which is, by associativity, you can go and multiply that 5 and that 2 and get 10. So you get 10c overall there. And that's true for any real c, okay? Whether c equals pi or 17 or Euler's constant or negative 12, it doesn't matter. C could be any real number. It could be a strange one just so it's real. It can be 0. That's fine too. But anyway, moving on. Let f of x equal this. Again, we just push the difference quotient. So we just get f of x, which is this guy, minus f of c, which is this guy. I went ahead, instead of putting in limit x goes to c fx minus fc over x minus c every time, I decided to just go ahead and cut to the chase. Okay, that's still true. You can still put that. That's still fine. And maybe even advisable when you're starting out, but I'd go crazy if I typed it in every time. So I just went ahead and cut to the chase right here. So here's f of x minus, here's f of c over x minus c. Now, guys, anytime you distribute a minus sign through these parentheses, you got to be careful. The left term, these leftward parentheses, I barely even need them. I really don't need them at all. I can just drop them. The right parentheses, you can drop them, but there's a price you have to pay. You have to distribute this negative sign through, and that's going to change all your negativities. So you'll get minus c squared, and then minus a negative, which is plus 3c, and then minus a negative, which is plus 5. So the negative 3, well, let's see, what cancels? Not as much as we would like, in a way, but it's okay, we'll be fine. The negative 5 and the positive 5 will cancel. That's nice. That's more important than you realize. So we get x squared minus 3x, and then we get a minus c squared, and then, now, don't forget that's a plus 3c there over x minus c, and you're like, well, Jason, okay, the numerator, it's not bad, but I don't particularly know how to proceed. Big hint. For the next step I'm going to do, we need to do difference of squares. So I had to go down to the next page, which is always aggravating, but let me get down here. So we got the limit x goes to c, and I recopied this. You know what? Actually, I use commutativity. I move the negatives. The next step I do is commutativity. I move the minus c squared over here, and I move the minus 3x over here. Okay, you got to move the corresponding plus or negative sign with the term if you ever move a term. Commutativity is fine. It's true. It's valid. You just got to move your negative signs with the term, or your plus signs. If you got a plus sign, like if he's going to move that plus 3c, you'd have to move the plus sign with the 3c. Or if he was going to move the minus 3x, you'd have to move the minus sign with the 3x. But anyway, so there's that. And then now you factor by grouping. Just factor the first, those first two terms only will factor as x minus c, x plus c. So just the x squared minus c squared will factor as to will factor into x minus c, x plus c. Now be careful here. Those last two terms are actually easier, but you have to be negative-wise careful. We're going to take out a negative 3. Now that's going to turn this into x minus c, because this plus sign here is going to turn into a minus when that negative 3 gets factored out. Be careful about that. Okay. This plus sign here turns into this minus sign here when we factor out this negative 3 here. Okay. But anyway. And then, now remember, factor by grouping, both of these terms have an x minus c in common, so you factor out that x minus c, and that's going to leave you with the x plus c, and that's going to leave you with a negative 3. So x plus c minus 3 to say the same thing right here. This is by Algebra 1 or Algebra 2, whichever. But hey, lo and behold, this x minus c will now cancel with this x minus c. So you're just left with the limit x goes to c of x plus c minus 3. And then, hey, that's just a polynomial, linear. So just throw c into x, and you get c plus c minus 3, which is 2c minus 3. And that's it. And yeah, we can do an example. You could do a concrete where you let c equal 5 or negative 5 or whatever you want it to equal. But anyway, there's that. Okay, so, and we can do this all day. Here's another one where you just push a limit, and we're doing the limit of the difference quotient, which is the derivative. The difference quotient is this fraction, as always. The limit of the difference quotient is the derivative, and that's our f prime. And then just do f of x is this thing right here. So f of x is just this, f minus parentheses f of c, which is the same thing except with c's instead of x's in it, over x minus c. Again, distribute the minus sign, and you're going to have to watch your negatives. You'll get minus c squared. Now minus a negative is plus 3c, and for the same reason, minus a negative is plus 5. And then the negative 5 and positive 5 will cancel. And then use commutativity to get your x squared and c squareds on one together, and your negative 3x and plus c together by commutativity. Then factor out 7 and do a difference of squares. You can actually, if you factor out 7, you'd get x squared minus c squared for these first two terms. But remember, I just go ahead and cut to the chase. X squared minus c squared is x minus c times x plus c. by difference of squares. And then on these last two terms, take out a negative 3 and change your negativities, and you'll get x minus c. But then you can factor out the x minus c that's common to both, and that leaves a 7 parentheses x plus c, and that leaves a minus 3. Now that 7 times parentheses x plus 3, that 7 is going to hit that x and that c by distributivity. So you'll get the limit x goes to c of 7x plus 7c minus 3, because these x minus c's are going to cancel here and here. And then I just go ahead and distribute that 7 through those two terms, through this x plus c right here. And then, hey, you have a linear polynomial again, or any polynomial is continuous. So just throw in that c, and you get 7c plus 7c minus 3, and that's 14c minus 3. You guys get the idea. We're just pushing limits. We're canceling. The golden step is when we cancel these x minus c's. That's probably the most valuable step. They all have their value, but this is the one we're looking for. If we can cancel that x minus c on that denominator, that's golden, because then we have continuity. We didn't have it here, but we do have it here. And we can just throw c in directly. If we had thrown c in directly here, we'd have been in trouble. We'd had 0 over 0, which is undefined. But if we throw c in directly here, we're in good shape. That's been true of all these that I've covered in this video so far. That's kind of been the morale, the motive, is to cancel those x minus c's. Okay. And then, again, I could do this again. Now, for x cubed, it's a little bit different. It's a little bit harder. You'll get x cubed minus c cubed up here, and you'll do a thing called difference of cubes from algebra. If you factor x cubed minus c cubed, it's x minus c in one set of parentheses, and in the other set, you'll get a quadratic x squared plus cx plus c squared. If you're a little rusty on that, just see your old algebra textbooks or whatever, or you're just finding an algebra book laying around. This is, you put x squared here, cx here, or you could call this xc by commutativity and multiplication if you'd rather. And then this is c squared right here. So, but hey, lo and behold, these x minus c's will cancel after we do our difference of cubes factoring. And that factoring that we did was called difference of cubes factoring. These x minus c's will cancel, and you're just left with this, the limit x goes to c of this quadratic polynomial. Hey, it's a polynomial. We're continuous. Just throw c into x. You get c squared plus c squared plus c squared. Oh, how do you like that? Because c times c is c squared right here as well. And then that's 3c squared. But hey, that's true for all real c. You might see a pattern here. You might see, like, later on we're going to find that the derivative of x cubed, or we're going to use the rules to find that the derivative of x cubed is 3x squared. And that's true. But I just, for any chosen point c, we got 3c squared. But anyway, we'll talk more about that later. There's a pattern. You may have noticed a pattern. If you're astute, you might have noticed a pattern already. This 3 jumps out in front of this x, and then this exponent, we dock it down by 1. We subtract 1 off this exponent. So x cubed, after we throw it into the derivative, we get 3x squared. They're not the same thing. What I'm saying is the derivative of x cubed is 3x squared. The exponent 3 comes down, and then that 3 that was up here turns into a 2. That pattern. If you saw that pattern, that's good, because there's some truth to that. Like up here, that 2 jumps down. Since there's a 7 there, it's going to have to multiply that 7. You'll get 14. So you get 14x. Now, how do you handle 3x? Well, you remember the derivative of negative 3x. The derivative of negative 3x is just negative 3. The slope, so that's just, or another way of looking at it, and we get the minus 3 there, but another way of looking at it is there's an understood 1 here, okay? And that 1 is going to have to multiply that 3, but that's just 3 again. And then with that 1 that was up here, we get, this is x to the 1 right now, but then after the fact, it's going, after we do the derivative, we get x to the 0, but you know what? X to the 0 is just 1, and 1 times 3 is just still 3. X to the 0 doesn't change anything. So, the exponent rule is still good. It's just in a weird, quirky kind of way. So the 2 jumps in front, and we get 14x, where the exponent falls down a power. So instead of 7x squared, after you do the derivative, you'll have 14x to the 1. And then instead of minus 3x, you'll have minus 3x to the 0, but that's just minus 3 himself. Okay, so that's where the exponent jumps in front, but I'll talk more about that later. But anyway, I'm not going to go through all these. It would take forever and ever. We get the idea. We kind of get the point. Here's another polynomial. This time I let c equal -4, just to show off that we can do negatives and that we have to be careful with negatives. But you do the same stuff. You have to be really careful with your negatives, and you're going to wind up, if you throw -4 into here, you're going to get, well, it's just use your calculator. You'll get something. And you know what? That -5 can go ahead and be sucked into things. That -5, we kind of go ahead and drag him into things, because he's just sort of loose. And by commutativity and associativity, -5, this negative, you know what? -5 and +5 are going to cancel. So really, he gets canceled before he can really do anything. So we're just left with that's -7 times 16, which is -112, or -112, and then this ordinary -12 here. And those combine to give you the -124. Now this is a little hard. This numerator, it's not totally obvious what to do with this numerator. You know what? You can factor it, but you're going to have to kind of think about it a while. That's not the easiest factoring to do in the world. As it turns out, you're just going to have to play with this until you find it, or use some algebra tricks. This numerator here will factor into this guy times this guy right here. You're just going to have to, there's some things you can do from algebra, but that would, it would take me a while to go through it, or you can just play around until you find this. You can just do guess and check. There's some other things you can do, but anyway, here's this. But lo and behold, the golden goose. You know what, guys? Never mind that. You know what? Usually math books, I'm not saying that if you factor this guy, you'll have to get an x plus 4 as a factor, but a lot of times your calculus books or what your calculus classes, they'll set it up that way. Your professors, your books, and all that, your courses have set it up to where x plus 4 will be a factor of this guy, even though in theory it doesn't have to be, And sure enough, it is. This x plus 4 is a factor of this original guy up here. And then you can tell, well, hey, if this is x plus 4, this would have to be a 7x, and this would have to be a -31, if it is true that x plus 4 is a factor, that is. But now, you do need to do the FOIL distributive and make sure that this product really does equal this guy right here. And if it does, you're in good shape. And I'm willing to wager that it will. So if it does, you're in good shape. You can cancel the x plus 4s. That's the golden goose. And you just get the limit x goes to -4 of 7x minus 31. Throw in -4. Be careful with your arithmetic. You'll get -59. So that's just a be careful kind of problem, okay? Just watch your negatives. Like up here, remember, -4 squared. You got to put parentheses around that -4 here and here. You'll get +16. And be careful here. You're minusing an already -12, so that's plus 12. But you know what? That plus 12 is going to bump into this minus sign right here, and it's going to become negative after all. So it's weird. You get this negative, but you got a third negative right here. So it winds up staying negative after all, because there's 3 negatives and not just 2 negatives. So watch out. But that's all for this video. Thank you, guys.